Once again, welcome to chemistry classes by Vijay Kumar Sethi, class 11th chemistry, unit 4, chemical bonding and molecular structure. And in this video, we are going to discuss about valence shell electron pair repulsion theory, that is VSEPR theory, and shapes of molecules in which the central atom has no lone pair electron. First of all, VSEPR theory. This theory provides a simple procedure to predict the shapes of covalent molecules. It was proposed by Sedgwick and Powell in 1940. It is based on the repulsive interactions of the electron pairs in the valence shell of the atoms, and it was further developed and redefined by Neylon and Gillespie. Okay, now main postulates of VSEPR theory. The shape of molecule depends upon the number of valence shell electron pairs. Now these electron pairs, bonded or non-bonded, around the central atom in a molecule or in a polyatomic ion. Pairs of electrons in the valence shell repel one another, since their electron clouds are negatively charged. These pairs of electrons tend to occupy such positions in space that minimize repulsion and thus maximize distance between them. The valence shell is taken as a sphere, with the electron pairs localizing on the spherical surface at maximum distance from one another. A multiple bond is treated as if it is a single electron pair, and the 2 or 3 electron pairs of a multiple bond are treated as a single super pair. When 2 or more resonance structures can represent a molecule, the VSEPR model is applicable to any such structure. In brief, we can say this theory is based on the total number of electron pairs surrounding the central atom. These electron pairs may be bonding or may be non-bonding. Okay, and these electron pairs occupy such a position that repulsion should be minimum. Okay, and to keep this repulsion minimum, the distance between them may be maximum. Okay. The repulsive interaction of electron pairs decrease in the order. Okay, first we can understand LP means lone pair and BP means bond pair. Lone pair means electrons which are not taking part in the bond formation, and bond pair, you are familiar, these electrons which make a bond. Repulsion is maximum between lone pair, less between lone pair, bond pair, and lesser is bond pair, bond pair. How? Lone pairs are localized on the central atom, and each bonded pair is shared between two atoms. As a result, the lone pair of electrons in a molecule occupy more space as compared to the bonding pairs of electrons. This results in greater repulsion between lone pairs of electrons as compared to the lone pair, bond pair, and bond pair repulsions. Okay. Now we will discuss the shapes of molecules in which the central atom has no lone pair. When there is no lone pair, geometry is regular, and these are the regular geometries: linear, trigonal planar, tetrahedral, trigonal bipyramidal, and octahedral. Okay. Now let us see, if number of electron pairs are 2, that is, and these 2 are bonded electron pair, then we can say this is the type of molecule AB2. A is a central atom and these 2 are the surrounding atom. If this is the central atom, and you can say this is the central atom A and this is the B and B. These are arranged in a linear way, and the bond angle between this bond and this bond is 180 degree. Examples are BeCl2, HgCl2. Okay. If number of electron pairs are 3 and all 3 are the bonded electron pairs, then we can say this is the AB3 type molecule. This is a central atom, and these are the 3 surrounding atoms arranged in a trigonal planar way. Okay, if you can say like this is a central atom. Okay, and these are the 3 surrounding atoms. If you join the center of these surrounding atoms, then we get the shape of trigonal planar, and the bond angle between this is 120 degree. Even this is also 120, this is also 120 degree. Example is BF3. Number of electron pairs 4. Then this is a type of AB4 type molecule. A is a central atom. Okay, so this is a central atom, and these B, you can say this is a 1B, this is B, this is B, and this is B. If we join the center of these atoms, then we will get the one geometry, and this geometry is called tetrahedral. Okay, you can also draw like this. This is a central atom. This is 1, this is 2, this is 3, and this is 4. This is a tetrahedral geometry. And bond angle, all the 4 bond angles, this one, this one, this one, and this one is same, and this is 109.5 degree. Actually, this is 109.28 degree. But approximately we will take it as 109.5 degree. Examples are CH4 and NH4 plus. Okay. Now, if number of electron pairs are 5, then this is AB5 type species. Central atom. This, now just see, this is a central atom. Now, in this case, how these 5 atoms or 5 bonds are arranged? Out of these 5, 3 are arranged in a plane making trigonal planar. Okay. This is B, this is B, and this is B, and one is above the plane and one is below the plane. This type of geometry or shape is known as trigonal bipyramidal. Okay, trigonal bipyramidal. Now, in this case, 2 type of bond angles are there. If you see the bond angle this, and this, that is in a plane, this bond angle is equal to 120 degree. And if we see the bond angle of this with the plane, okay, with the plane, then this is 90 degree. In the same way, bond angle of this B with this plane, this is again 90 degree. 2 type of bond angles, 120 degree and 90 degree. Example is PCl5. Another one is, if number of electron pairs are 6, then this is AB6 type species. This A is a central, okay, and these 6 surrounding atoms are arranged in an octahedral manner. How? This is A. Now, out of 6, 4 are arranged in a plane, making a one square planar, and one is above the plane and one is below the plane. This is octahedral geometry. Okay, in this case, all the bond angles are 90 degree. Example is SF6. Clear? Now you can also see the shapes of molecule in which central atom has no lone pair, like BeCl2. This is a linear. This is central atom. This is surrounding. This is Be. Okay, and this is Cl and this is Cl. This is a linear, bond angle is 180 degree. BF3. This is B, and these 3 are F. If you join the center of these, we will get the trigonal planar geometry, and bond angle is 120 degree. CH4, this is C, and these 4 atoms are hydrogen. If you join these center of these atoms, we will get a tetrahedral geometry. PCl5, that is, if 5 bonded electron pairs are with this central atom, then this is phosphorus. Okay, again see, this is phosphorus. 3 bonds are in a plane, one, and these are at 120 degree. This is 120, this is also 120, and this is also 120. And one is above the plane and one is below the plane. The bond angle between this plane and this bond, that is 90 degree. That's why two type of bond angles, 90 degree and 120 degree. Okay, trigonal bipyramidal. Now, dear student, one question arises: how can we find out these total number of electron pairs surrounding the central atom? Okay, there is one formula, and this formula is applicable for most of the species at your standard. Okay, for more, not for all, but for most of the species. Total number of electron pairs around the central atom in a species, that may be neutral or they may be charged. This is half of the number of valence electron in free atom plus number of monovalent surrounding atoms. Monovalent means having valency 1, and this is plus minus charge. If positive ion is there, then subtract. Okay, positive ion is there, then subtract whatever the charge, positive charge is present, and if negative charge ion, that is negatively charged species there, then add whatever the charge present on that negative species. For example, NH4 plus, what is its shape? Okay, if we apply the formula, total number of electron pair, how can we find out? In this case, central atom is this nitrogen. Then if nitrogen is free, then how many valence electrons are there? In case of nitrogen, 5 valence electrons are there. That's why half of the 5 plus monovalent surrounding atoms, these are the 4. That's why 4. And there is one positive charge. That's why minus 1. If you solve it, you will get the 4. It means total number of electron pairs are 4, and all these are bond pair. How you can say that these are the bond pair? Because nitrogen is surrounded by the 4 hydrogen atoms. That's why these 4 are the bond pair of electron. And when 4 are the bond pair of electron, they are arranged in a tetrahedral manner. This is N, this is H, this is H, this is H, and this is H. This is a tetrahedral manner. Okay. Now see one more example. If you are having SO4 2 minus, SO4 2 minus, okay, then again half of the number of valence electron in free atom of for sulfur valence electrons are 6 plus number of monovalent surrounding atoms. Now dear student, in this case surrounding atoms are oxygen, but oxygen is not a monovalent, oxygen is a divalent. That's why this is 0. Now negative charge is there, and that is minus 2. That's why you will add plus 2. And if you solve it, this will come to 4. That's why this, in this case, the sulfur is again having, that is sulfate ion having the tetrahedral geometry. This is S, this is O, this is O, this is O, and this is O, and total negative charge is 2 minus. Okay, now in this case ammonia, you can make ammonium ion. This is H, this is H, this is H, this is H, and total charge is 1 positive. Okay student, now thank you. Subscribe my channel. In the next video we will discuss about the shape of molecules having one or more lone pair of electrons.